For millennia, humanity has gazed at the sun, awed by its power yet mystified by its inner workings. Now the Parker Solar Probe is changing that, sending back images so detailed they're rewriting our understanding of our star. Its latest data, received in July 2025, offers an unprecedented window into the sun's corona, the outer atmosphere where plasma and magnetic fields perform a violent, beautiful dance. For the first time, we're seeing storms larger than Earth merge and race outwards, reshaping our models of solar physics. The probe's journey into this extreme environment is a triumph of engineering and curiosity, pushing technology to its limits. These images are more than pictures, they're a Rosetta Stone helping us decode the sun's language. The clarity of this data is already answering questions that have puzzled scientists for generations and raising new ones. This isn't just academic. The sun's moods drive space weather, affecting our technology and daily lives. By understanding our star, we learn to protect ourselves. The Parker Solar Probe's daring mission marks a new era in solar exploration. This is the story of the probe that dared to touch the sun. The Parker Solar Probe's journey began decades ago, inspired by Eugene Parker's 1958 theory of the solar wind. Launched in 2018, the probe was built to survive the sun's inferno, shielded by cutting-edge carbon composite armor. Its mission: fly through the corona, sampling particles and magnetic fields where temperatures soar to millions of degrees. In December 2024, Parker made its closest, most daring pass, just 3.8 million miles from the sun, 7 times closer than any spacecraft before. From this vantage, its wide-field imager captured the corona in astonishing detail, revealing structures invisible from Earth. Over 7 years, Parker has used Venus's gravity to inch ever closer, each orbit delivering new data and insights. The probe's resilience is a marvel, and every flyby brings us closer to the sun's secrets. As project scientist Noura Wafi says, each pass is a milestone in our ongoing voyage of discovery. The latest images are not the end, but a spectacular turning point. The Parker Solar Probe returns a torrent of data, terabytes of complex signals from the sun's corona. To make sense of this, scientists turn to artificial intelligence, training algorithms to spot patterns in plasma flows and magnetic fields. AI whispers images with superhuman speed, tracking plasma clouds and identifying faint structures lost in the sun's glare. This partnership between human insight and machine learning transforms raw data into discovery. AI can tag and follow multiple solar eruptions, building dynamic 3D models of these events. It doesn't just see images, it understands the physics, helping decode the sun's behavior in real time. This marks a new era. We're not just observing, but actively interpreting the cosmos with intelligent tools. The latest revelations are as much a triumph for AI as for astrophysics. Parker's AI-decoded images have revealed a first merging solar storms. We've long known about coronal mass ejections, or CMEs, but now we see them colliding. Smaller eruptions overtaken by larger ones, forming monstrous waves of energy. These cannibal CMEs are far more potent, and understanding their birth is key to predicting extreme space weather. The probe's data shows shock waves and turbulence as plasma clouds collide, amplifying magnetic fields and accelerating particles. Parker also captured the heliospheric current sheet, a vast, rippling surface separating magnetic regions, now seen as a shimmering river of material. This high-resolution view reveals the sun's magnetic influence shaping the solar system. The solar wind is not uniform, but a complex tapestry woven from magnetic fields. These images are our first detailed maps of this hidden architecture. The sun is finally revealing its structure to us. The solar wind, a stream of charged particles, has puzzled scientists for decades, especially its slow, gusty form. Parker was designed to fly through the wind's acceleration zone, sampling its properties before they change on the way to Earth. The probe's data reveals the slow wind isn't a single entity, but two distinct types with different origins. This breakthrough lets scientists trace each wind back to specific solar features, revolutionizing our models of the sun's energy release. The corona is now seen as a patchwork of regions, each producing unique solar weather. Understanding these distinctions is crucial, as the slow wind and embedded CMEs most often impact Earth. Parker is not just observing the wind, it's charting its sources for better forecasting. Parker's data has finally distinguished the two types of slow solar wind. The first, Alfvénic slow wind, is marked by magnetic switchbacks, rapid reversals found near coronal hole edges. These turbulent bursts help accelerate the wind, revealing a core mechanism of the solar engine. The second, non-Alfvénic slow wind, is smoother and originates from helmet streamers, tall magnetic loops above the sun's equator. Here, plasma leaks from closed loops, creating a denser, sluggish outflow. By identifying these sources, Parker has solved a decades-old puzzle. The slow wind is a blend of at least two flows. Only by venturing close to the sun could we untangle these threads. This knowledge is the foundation for better space weather forecasting. We're finally mapping the sun's winds at their source. These discoveries have real-world impact. Our technology is vulnerable to the sun's violent outbursts. Major solar storms can unleash energetic particles and magnetic fields threatening power grids, satellites and even astronauts. In May 2024, a solar storm caused $500 million in damages by knocking out GPS systems during a critical planting season. The infamous Carrington event of 1859, if repeated today, could cause trillions in damage and global disruption. Parker's mission is vital. By understanding how storms form and tracing the solar wind sources, we can build better predictive models. Like hurricane forecasts, solar storm warnings can help protect infrastructure and lives. The knowledge from Parker is not just for science, it's an investment in our civilization's resilience. Understanding the sun is key to safeguarding our future. The Parker Solar Probe's journey is far from over. Its next close approach is imminent, promising even more detailed data from the sun's mysterious corona. Each pass brings us closer to the heart of solar activity, revealing new layers of complexity. Scientists are eager to see if switchbacks become more frequent and to map the sun's magnetic structures in higher resolution. The mission stands as a testament to human curiosity and ingenuity, connecting us to the star that sustains us. The data Parker gathers will inspire new discoveries for decades. The universe is full of wonders, and our quest to understand them continues.